some people say that that the future of the electricity market might even be like Uber, where it becomes so deregulated and so many players in the market that you can basically buy electricity on a daily basis from your phone. Now, whether that happens or not, some people will say that's impossible. But, I like to say, if it can happen, it will happen. Always takes a little longer than you think. And there's nothing like a little bit of regulatory support to make things happen.
What's up, everyone, and welcome to the Renewable Energy Smart Pod. I'm your host, Sean McMahon, and that voice you just heard was Bob Yeager, the president of Power and Water Solutions for Emerson. The energy industry is evolving rapidly, and Bob is here to talk about some of the trends that are driving that evolution. Specifically, the 3 Ds: decarbonization, decentralization, and digital transformation. We had a great conversation, packed with loads of insights from Bob, so I think you'll enjoy listening to it. Looking ahead to future episodes of this podcast, nearly every guest we've had on this show has spent at least a few minutes talking about the grid. And yes, Bob and I spent some time talking about the grid today too. But we've never dedicated an entire episode to the grid. Well, that's about to change, because Rob Gramlich from Grid Strategies will be joining me in the coming weeks, so he and I can spend a whole episode doing nothing but geeking out about the grid. And remember, if you want your renewables news in email format as well as podcast, head on over to smartbrief.com and sign up for the Renewable Energy Smart Brief. And as always, you can follow this show on Twitter, where our handle is @RenewablesPod. Before I kick off my conversation with Bob, here's a quick word from the exclusive sponsor of today's episode, Emerson.
Emerson has a deep legacy of helping our customers in the world's most essential industries solve the most complex challenges of modern life. Our breakthrough software and technologies drive innovation that makes the world healthier, safer, smarter, and more sustainable. Emerson, consider it solved.
Hello, everyone, and thank you for joining me for today's episode. My guest is Bob Yeager, the president of Power and Water Solutions at Emerson. How you doing today, Bob?
I'm doing great, Sean. Thanks for having me.
Yeah, I'm excited to chat with you here. We got a lot of ground to cover. But before we get into the thick of everything, why don't you just tell our listeners a little bit about your background, and how long you've been in the industry?
Sure thing, Sean. Well, actually, I've been in this industry a long, long time, almost 40 years. I started out as a field engineer in the early 80s in the nuclear group. So I did startups of the 1,000 megawatt pressurized water reactors. I moved on from there into the fossil side of the business, so coal and gas, and then from there into projects, and ultimately had the honor and privilege of running the research and development group for Westinghouse Process Control at the time. And then we were acquired by Emerson in 1998, and it's been 20 years in this industry since we joined Emerson.
Wow, so 40 years. So you're telling me you're a rookie, huh? You're a newbie?
Yeah, yeah. Still a rookie in many ways. Still learning, Sean, every day. The way the market is going and the grid is changing, it's always an adventure. That's for sure.
That sounds great. So I'm not going to ask you to outline all the things that have changed in 4 decades, but let's just look back the last 5 or 10 years. What are some of the most significant developments in this sector?
Sure thing. So, I like to put it in basically 3 categories. It's decarbonization, which I think everyone knows about. It's decentralization and digital transformation. So we know that with all the regulatory issues around the world and the negativity towards carbon, the decarbonization of the global generating infrastructure is and continues to be a high priority. And it's creating some really good things and some not so good things. And then decentralization, as that decarbonization occurs, we're transitioning from these, I like to think, these massive amounts of spinning metal for maybe 1,000 megawatt coal unit or an 800 megawatt combined cycle unit to distributed energy and microgrids that could be maybe a gas turbine, but wind and solar. That creates some issues with respect to reliability and just grid distribution. And then digital transformation, as there's more complexity in the grid and maintaining the grid and the bidirectional flow of electricity, there's more of a need for software and analytics that we've seen dramatically increase in the last 2 or 3 years.
Okay, so it sounds like all three of those things are pretty well tied together, so to speak. So what's the most crucial piece? Is there a crucial piece, or are they all three kind of equally important?
Well, I would say they're all equally important, but certainly the decentralization is creating a lot of interesting grid dynamics because, as we all know, the grid is very sensitive to frequency. So in the United States, that grid has to run pretty much at 60 hertz. And, at a tenth of a hertz variation, I like to say somebody's opening valves somewhere, because if the frequency varies too much, some bad things happen. You can get equipment damage. There's a lot of trip circuits that go into effect, and the result can be brownouts or rolling blackouts that we've seen in the United States recently. So, there's one thing that keeps the grid stable, and that's inertia. And inertia is basically the instantaneous conversion of rotational energy to electricity. And that's great for fossil fuels. For coal and gas, you have, again, these large spinning masses of metal. But in wind and solar, for example, there's really, some people claim there's synthetic inertia, but there's really no inertia. It's really DC converted to AC, and there isn't this massive dampening effect on the grid. So as more and more renewables come into play, it creates issues with frequency and ultimately grid reliability.
Yeah, and you mentioned some of the issues that all this creates. So what are some of those challenges that the industry is facing, and what are some of the ways that folks like yourself are looking to tackle them?
Well, challenges, across the board. Challenges, in fact, was interesting. On the front page of the Wall Street Journal today, I was preparing for this, it says, coal shortages weigh on global economics. The issue is, as the economy recovers and there's more demand for electricity, the fact is that about 40% of the world's terawatt hour consumption still comes from coal, and maybe a little less than that from gas. So you have these enormous amounts of fossil fuel generation driving the economy. And what's happened just in the last 6 months, because of this surging demand, coal prices have tripled. I think today it's like $200 per metric ton. I checked the gas spot price this morning. It's $5.61 per MMBTU. That's a Henry Hub. That's tripled in the last 6 months. So this decarbonization effect, well, it's good for CO2, can have hidden effects on the economy and reliability. So that is I believe one of the biggest challenges we face is, how do you balance decarbonization? Everyone wants a clean environment. No one's arguing about that. With global economics, and just, when people turn on the light switch for electricity, they expect the electrons to flow. So you have this natural flashpoint there. That's probably the biggest challenge, is how do you balance that going forward?
So is it a balance, or is it kind of the speed of the transition? Meaning, like, if we kind of, everyone wants to crank up wind and solar and everything real fast, but does that put the economy in danger of some of the situations and the pricing that you're talking about right now? And is there an optimal pace, I guess is what I'm asking, at which the transition should take place?
Well, that's an interesting question. A lot of it's somewhat political. There are advocates for 100% renewable energy, and it's certainly an admirable cause. I think everyone would love to have zero carbon emissions, but the balance is really the challenge. I'm not sure what speed or pace you can do that. I think what we need to do is all take a step back and look at the impact it's having on grid stability. Everyone's heard about what happened in Texas, in the cold snap. That was a direct example of low spinning reserves, right? It's really no one's fault. I mean, it was a combination of market dynamics. People worked really hard through that, but it was a combination of market dynamics, cold weather, lack of spinning reserves, unavailability of the renewables, frequency dipped, and a near catastrophe in Texas. Some people would say, well, that's because of renewables. Some people say, no, it was really the market dynamics. So I think it's, really, you got to take a step back and kind of look at all these things together. There is really no simple answer for that.
I understand. And you mentioned decarbonization kind of right at the top there. And so obviously with COP26 coming up, where there's a kind of a global focus is, really being sharpened on sustainability goals and net zero and things like that. So what's the role of the power industry in that? Obviously, it's going to play a huge role in decarbonization, but how all those announcements get rolled out or even what they are. What's the role of the power industry there?
Yeah, well, the power industry certainly has a lot to do with CO2 global.
Yeah, certainly.
So I would say if you point to somebody, I like to put it in perspective. If you think about, and I like to look at it globally, because if you just think about CO2 emissions by country, China, by the way, we have 1,000 systems in China. So I like to say we're in the trenches. We have 1,000 automation systems, mostly the 600 megawatt units and 1,000 megawatt units, the coal units. So we have a finger on the pulse in China. So they emit 11 million kilotons of CO2 per year. 11 million kilotons. US about 5 million kilotons. India about 2.5. But interestingly, if you look at it per capita, the US is about 16 metric tons per person, and China is only about 7. So, when you look at decarbonization, also if you look at megawatts on the ground installed per 1,000 people, that's the generation available. US about 3 megawatts per 1,000, China 1. So you have this, this dynamic going on where there's this push for, decarbonization on one hand, but the generation needed in these emerging markets like China, they need the electricity. You read in the recent weeks as well, also in the Wall Street Journal, that there's electricity shortages in China, mostly because of coal. But they're saying, look, I know we need to be smart on decarbonization, but we need the power, right? So they're still building coal units. Southeast Asia is still building coal units. So you have this kind of also a natural flashpoint there between decarbonization globally and the demand and need for electricity.
Yeah, and I know those new coal units are a little bit controversial, you could say, because obviously when they stand them up, they're going to be up for a few decades, So
they do. They run 20 to 30 years.
Yeah. So looking domestically, what are some of the things you see coming down the pipeline, either from the industry or from government agencies or things like that you think have a good shot of kind of helping tackle not only the wider decarbonization aspect of things, but you also mentioned the distribution of energy?
Yeah, so interesting new regulation from FERC, FERC 2222. And that is it's not into effect yet, but the ISOs and the RTOs have, I think, within the next year to respond. But basically what it says is that the US market, FERC wants to open the US market to all kinds of distributed energy resources and all products into the electricity market. So distributed energy, distributed storage, frequency response, spinning reserves, not from just traditional fossil sources, but from all sources, including what I like to think of as virtual power plants, where you could have, I mentioned earlier, like a microgrid with a 200 megawatt gas turbine and some wind and solar. But the key is that it's dispatchable. So, the idea is that you can have this renewable source of energy, a combination of renewable energy and fossil energy that appears to the grid like 1,000 megawatt coal unit. It's dispatchable, but yet it's this mixture of renewable and fossil energy. So from a mix structure, FERC 2222 will address that, but then also from a market and economic structure, some say that the U.S. electricity markets are somewhat dysfunctional for many reasons, and that's also somewhat a political view. But FERC 2222 says also that in addition to this gradual mix or allowable mix of more renewable resources, that the market dynamics will change so that the virtual power plant down the street, this dispatchable 1,000 megawatt virtual power plant that looks just like the coal unit, can bid into the market just like the 1,000 megawatts. So the idea here is to make the market even more open than it is. Some people say that that the future of the electricity market might even be like Uber, where it becomes so deregulated and so many players in the market that you can basically buy electricity on a daily basis from your phone. Now, whether that happens or not, some people will say that's impossible. But, I like to say, if it can happen, it will happen. Always takes a little longer than you think. And there's nothing like a little bit of regulatory support to make things happen.
I gotcha. So, and just to take that Uber analogy and pull on that thread a little bit. So these virtual power plants, I mean, so Tesla made a big splash a couple months ago, kind of talking about how all their power walls could be kind of pulled together as a microgrid itself. So do you see more of this happening from batteries like that? Or do you see more of it happening from the standing up of wind and solar assets and kind of pooling those together, or will be all three of them together? I don't know.
Yeah, Sean, it's actually all because, the virtual power plant certainly will play a role with this new architecture and new infrastructure, but energy storage and battery storage has really come a long way. There's still many are counting on new battery technologies that will emerge eventually. But even with the current technologies, the lithium technologies today, there are battery storage units being built in the United States that are, a gigawatt. There's several in California around the United States that are creating this basically storage of electricity, which, by the way, can provide an effect in inertia, right? Because they have this stored energy. Now, not as long as turning a valve, changing the valves on a coal unit, but certainly for several hours, you have a gigawatt of generation available that can make a difference. So between the battery storage, between the virtual power plants, and this still mixture of fossil generation, you can see how all come together to change the landscape.
We're going to take a quick 30-second break. But when we come back, you'll hear Bob explain how improved analytics might have reduced the severity of the Texas power crisis. And you'll also hear his bold predictions about the future of the energy industry.
As a global innovator, Emerson has a deep legacy of helping our customers in the world's most essential industries solve the most complex challenges of modern life. Powered by a community of problem solvers with industry-leading expertise, we deliver sustainable grid solutions that increase efficiency, reduce emissions, and conserve resources. Our breakthrough software and technologies seamlessly integrate renewable and distributed energy resources into the power network for a more reliable and stable electric grid. We drive innovation that makes the world healthier, safer, smarter, and more sustainable. Emerson, consider it solved.
And now, back to my conversation with Bob Yeager. So you mentioned the power crisis in Texas earlier this year in February. You can also look at other events like the California fires and Hurricane Ida. So very, very recent things that I think are starting to kind of wake people up to the importance of the grid. I mean, I think a lot of folks had no idea that Texas was kind of on its own grid and couldn't really bring in a bunch of power from other states when they needed it. And also, just the resiliency factor. Hurricane Ida comes ashore or these fires come in and people are out of power for days. So what technologies are available today or in development, kind of just around the corner that kind of help stabilize the grid and make the grid more resilient to events like that?
Sure. Well, it's a couple of things. From a physical perspective, you mentioned that ERCOT doesn't have an interconnect. There are those that are advocating that, look, ERCOT should no longer be an island on itself, but it needs an interconnect. That's a physical thing. There's also, the grid infrastructure has been around a long, long time and it's aging. So just if you look at the major U.S. utilities and you look at their capital forecast over the next, 3 to 5 years, they're spending massive amounts of billions of dollars of their capital in grid infrastructure improvement. It's not only just the rebuilding of the grid that exists today, but also extending the grid to support these distributed energy resources that are coming on the renewable generation. So it's sort of a physical layer that's happening that will help with grid resiliency. What we talked about earlier is you have to understand inertia. That is something that in most physics courses you study what inertia is, but many people don't understand how important inertia is to the dampening effect of the grid. That comes from rotational energy instantaneously converted to electricity. That you have to be, whether it's synthetic or from a battery, you have to understand you need enough inertia in the system. And then from a digital transformation perspective, software is really becoming a big issue and an important factor in just understanding between, the analytics that are available now and end-to-end connectivity from generation through transmission and distribution all the way to the meter, understanding the analytics of the grid and being able to do things like load shedding, intelligent load shedding when there is some event that happens. what happened in Texas was, I think within 15 minutes, they had to shed 10,000 megawatts, which is an issue to begin with, but I'm not sure that they actually had the optimal strategy for shedding those 10,000 megawatts. But if you had improved analytics and software that could automatically or maybe optimally shed the load, you could have avoided some of the rolling blackouts that occurred. So it's this, digital transformation and physical infrastructure that they're really going forward will make a difference.
And so you mentioned that a lot of the utilities are spending big on that. Are there any companies out there that are kind of doing the same? I mean, we read a lot about, the Amazons and the Googles and things like that, like standing up their own power resources. And I think there was, I don't know, I'm not going to name the name, but there was a chip manufacturer down in Texas that was offline for a few days and it cost them tens of millions of dollars. Here we are already in a global chip supply crisis, and then they were offline. So are there any companies out there that are just kind of seeing that, hey, if we invest in this, stand up our own generation sources, our own power, I guess is what I'm trying to say, so that they kind of don't have to worry about being knocked offline by some of these things? And are there any companies doing that, and who's leading the way?
Actually, Sean, that concept is not new. There, over the years, there are many large manufacturing facilities or critical resources that have their own power block, so to speak. It could be just a couple of gas turbines, some recip engines. It could be a full combined cycle that they actually have their primary source of electricity as their own. And what they do is it's sort of a redundancy. They still have the connection to the grid, of course, in case their power block would go down. But they have that just to protect, the process that you talked about in chip manufacturing or pharmaceuticals and life cycles. I mean, if they lose power, there's millions and millions of dollars a day that they impact on their business. So the difference is, so that's been around for a long time actually. But, as the market deregulates and we see regulation like FERC 2222 that allow much more open participation in the electricity markets, you might see more, not so much power blocks being built for these critical manufacturing resources, but these virtual power plants being built just because they want to get into electricity generation as a business. So they say, look, I'm going to create a virtual power plant. I'm going to create my own company, so to speak, and the market's wide open. So I'm going to, maybe it's an ancillary service. Maybe I'll provide spinning reserve. Maybe I'll provide frequency response. And as the market opens up and pays for those things, then I think you'll see more and more businesses get involved in that, which is good for the market and much better for grid reliability as well.
You just mentioned how during the Texas crisis, if some of the systems had enhanced analytics, the crisis might not have been as severe because they, when they shed the load, it could have been done in a more optimal way. Let's dive deeper into that whole digital transformation. So what does that look like for the power industry, not only in a crisis like Texas, but also just in day-to-day operations? Like how much can that enhance the performance and cut costs and things like that?
Sure. So obviously analytics can help on all fronts. No, it's not just load shedding and optimal dispatching and those kind of things, or automatic generation control certainly can help there. But what's also an issue certainly in the North America power industry is aging workforce. We just started this conversation, but I've been here 40 years, right? So if you look at our industry, there are many, many experts in the industry who, you don't learn about the power industry or a process in a power plant and how all these things work in, 1 or 2 or 3 or even 5 years. It's 10, 15, 20 years. So you have, this massive amount of knowledge that over the next 10 to 15 years will transition. You'll have the next generation coming in. So what digital transformation can do, not only from analytics and an operational perspective, but there are things like digital twins that can create not the virtual power plant that I was talking about, but work with me on this. It's a virtual power plant. Okay, so the virtual power plant I was talking about is actually you put together some mix of generation and it becomes a dispatchable virtual power plant. A virtual power plant is a complete software version that looks and feels and acts and behaves as the same 800 megawatt combined cycle or the 1,000 megawatt coal unit or a hydro generating unit. So when you sit down in front of the operator console or the engineering console, all of the first principle thermodynamic models are there. It's totally synchronized. This is the breakthrough in technology in the last 3 to 5 years is simulation is not new in power. That's always been, the nuclear industry has had it since forever. But they were always kind of standalone digital twins and kind of worked on their own. Now the next generation of digital twins is actually integrated with the actual real power plant. So you have this sort of bidirectional flow of data from the real environment into this virtual world. So the next generation can come in and try things, look at logic, learn. They can actually trip the unit as if it would trip offline. Of course, not the real unit, and experience that instead of firsthand in the plant. This virtual environment, the ability to learn more quickly is incredibly enhanced.
Yeah, so the virtual power plant. I gotta look.
Virtual power plant.
The VVPP or the V2P2.
Yeah,
I can see that
right.
acronym already flying around.
Yep.
What about cyber? I mean, so obviously Colonial went through some things earlier this year. So what role, where does digitization play in enhancing the cybersecurity of the grid?
Yeah, so for sure, cyber is an issue. It's one of those, you tend to hear about it every day, and there's always an issue that's somewhere. We know for sure, this is not new either, that there are state-sponsored groups, with hundreds of thousands of people that when they come into work every day, their job is to try to hack into basically whatever they can, and that's a fact of life. So what I believe, from a product perspective, what we do, we have a heightened awareness of this, and we have a very layered effect approach to it. At the low level, the operating system level, we design and develop our code to be, not 100% immune to cybersecurity, but certainly robust embedded in our system. Then layered on top of that, there's antivirus and intrusion detection, malware detection, sort of that layer. There's a third layer called cyber analytics that will look at traffic on the network and say, these IP packets that are floating around the plant, they look a little suspicious. I've seen this footprint, at another site, and you better watch out. So here's a plan of attack and a response plan or playbook to respond to that. And then our fourth layer is legal protection. Heaven forbid, the Department of Homeland Security has something called qualified anti-terrorism technology that basically provides legal protection to the end users should something terrible happen. That's from a vendor perspective. From a user perspective, really there's three things that you really have to be done. Is you have to first do an analysis of what you have and understand what is it that I have, where am I vulnerable, just understanding what the infrastructure is. The second thing is, what's my strategy? What's my defense strategy? How will I protect? How will I optimize my cybersecurity strategy? And then the third thing is just continuous review. Because the one thing about cyber software, it has a much, much shorter life cycle than automation software because things change so quickly. So you have to have this constant review. And if you do those three things, you have a good chance of not being. Of course, you're always at risk, but at least protecting yourself.
Understood. So where does Emerson fit into all this in terms of the role you play and offerings when it comes to this digital transformation? You guys play a huge role. So where's your footprint, specifically in renewables?
Our automation system, I'm sitting here in Pittsburgh, Pennsylvania. This is our global headquarters, and we have offices all around the world, and we have systems all around the world. We have on the ground, we have 1.6 million megawatts, which is about 20% of the global generating capacity. If you walk into the control room, you're going to see, our equipment. In the United States, we have about 475,000 to 500,000 megawatts nameplate generating capacity. So roughly about half the U.S. generating capacity for mostly the large units. If you walk in the control room, you're going to see our system. In China, I mentioned we have 1,000 systems. So all around the world, we have this automation infrastructure for all fuel types: coal, gas, nuclear, hydro, solar, wind, geothermal, battery management, battery storage. So we have this large infrastructure. We also have cybersecurity, the four layers of protection that I described. We advocate that. We deploy that. We work globally with end users on cyber strategies. The three elements that I just mentioned to you is very important. And then the analytics software and the digital twin software, I like to think we're somewhat of a pioneer in that. We have about, I think altogether, we probably have 40 to 50 million lines of code. And that digital twin is probably 8 to 10 million lines of code total. So a lot of software that we've introduced for the power industry. And like I said earlier, we're kind of in the trenches and we're close to what's happening there. So, as far as strategies going forward, because we see every day, you can see the maps behind me. I have, if I would show you the rest of the room, I pretty much know where every power plant is in the world. Okay. And we know what happens on a daily basis. If a unit trips off in India, trips offline, we know it, and we can detect it and we can respond to it. Hopefully it's not our problem. Sometimes it can be, but we look at, sort of the global generation pattern, global generation strategy, but, from all the things we talked about, decarbonization and decentralization, that's how we, keep in touch with a global generation, and then make sure that I like to think we're stewards of the industry. Yeah, we have products and things that we sell, but I don't think that's why always people buy from us. I think it's because of our knowledge and know that we understand the industry and are here to protect the industry and our customers.
Based on all this conversation we've had about what the grid looks like now, what power generation looks like now, and what it's going to perhaps look like in the near future, do you have any bold predictions about what that future will look like?
Bold predictions. Wow. I think the last 3 or 5 years have been pretty bold. I mean, it just what's going on. I mentioned the Wall Street Journal every day. I love to just look at the Wall Street Journal. Usually there's something about power generation on the front page. It's it's unbelievable. But as far as bold predictions, I think the challenge that will be faced is this. I mentioned earlier, this natural flashpoint between this huge surge for renewables and decarbonization, which is a good thing. No one's arguing that. And also the absolute critical need to preserve grid reliability and inertia in the system and how we balance and protect the economy, because all three of those come together. If we don't have a good strategy on that, it could be totally dysfunctional like we have seen. So that'll be a real challenge for the global infrastructure as we go forward. Market deregulation certainly always creates new issues, but this is not the first. In the mid 90s, the ISOs and the RTOs were formed and the market was deregulated. This is not new. All of the U.S. utilities actively participate in that and are major. So it's not necessarily that always happens, but it will create some interesting dynamics. But certainly, I think U.S. utilities are up for the challenge there.
Okay, great. Well, I've really enjoyed our conversation today. Learned a lot about what the future is going to look like and the role that companies like yours will play in it. So I really appreciate your time, Bob. Thank you very much.
Great. Thanks, Sean.
Now it's time for the PODBRIEF segment of today's episode, and I just want to take a minute to point you toward a couple of resources I think you might find interesting. As always, I'm including links to these sources in the show notes, so head to today's episode page to give them a read. First, if Bob's comments about energy markets perhaps one day looking more like Uber, where you buy your energy on your phone whenever you need it, Bob has an entire LinkedIn post where he explains that concept in greater detail. It is definitely a cool concept that might one day become the norm. Second, Nick Ferris over at Energy Monitor published a fantastic piece recently about the so-called reliability of fossil fuel energy sources. Critics like to slam the intermittency of wind and solar, but recent events like the Texas freeze and the energy crisis going on in places like the UK, Europe, and China call into question the myth surrounding the always-on reliability of oil and gas. Plus, the rise of battery storage means the intermittency of renewables will be smoothed out as more hybrid projects come online. Nick breaks it all down with some excellent data, so be sure to check out that article. Oh, and one more note. With COP26 less than a month away, we've got some special episodes on tap here at the Renewable Energy Smart Pod. One in advance of the conference to talk about expectations, and another after everything wraps up in Glasgow to talk about the key takeaways. If you or someone you know might be keen to share your expertise as it relates to COP26, I'm including my email address in the show notes so you can get in touch. And you never know, I might even bring you on the show so others can hear your insights. Well, that's all for today's episode. Before we go, I want to say one more thank you to the exclusive sponsor of today's podcast, Emerson. If you like this podcast, please share it with your friends and colleagues. And be sure to follow us on Apple, Google, Spotify, or wherever you get your podcasts. You can also follow us on Twitter, where our handle is @RenewablesPod. And if you'd like a daily dose of renewable news delivered to your inbox, head to smartbrief.com and sign up for the Renewable Energy Smart Brief. The Renewable Energy Smart Pod is a production of Smart Brief, a future company.